Consider the next equation. Two of the roots of this equation are. Find the possible values of a. We know that if a complex number is a root, a complex conjugate is also a root. Hence, the third root is a minus bi and b minus ai are also roots. Hence, we know all four roots. And we know that if we substitute a root in the equation, it must be true. So the first way is to substitute roots and get simultaneous equations, but it looks very complicated. Also, we know some formulas for the sum and the product of roots, and let's try this way. So we know that sum of roots formula is given in the data booklet, and sum it's minus this coefficient divided by this coefficient, so it's minus 4. And let's consider the sum. So a plus bi plus a minus bi, hence it becomes just 2a and plus 2b. And product it's negative 1 to the power of n, it's 4, so it's plus this coefficient divided by this coefficient, so it's 400. And product looks like a plus bi multiplied by a minus bi. It's a formula a minus b, a plus b in general, which is a squared minus b squared, so it looks like a squared minus bi squared, which is I squared is negative 1 minus plus, so it's a squared plus b squared, and b plus ai multiplied by b minus ai, it's also a formula, so it's also a squared plus b squared, and it's 400. And let's try to solve this, and we can see that we can divide by 2, hence a plus b, it's negative 2, and a squared plus b squared is positive, and we can deduce that a squared plus b squared, it's a square root of 400, which is 20. And let's try to solve this, and we can square the first equation and get that a squared plus 2ab plus b squared is 4, and a squared plus b squared is 20, so we get that 20 plus 2ab is 4, hence 2ab is negative 16, hence ab is negative 8. And we can consider a plus b is negative 2 and ab is negative 8, and we can solve by substitution. For example, a is minus 2, negative 2 minus b, hence, or actually, since we need a, let's consider b is negative 2 minus a, and a, we can factor out minus, and minus cancels, so it's a 2 plus a is 8, and since it is given that a, b are integers, we can just consider product of two integers to be 8, but in general it's a quadratic equation, it can be easily solved. So the product is equal to 8, or actually let's solve with discriminant. So it becomes a squared plus 2a minus 8 is equal to 0. Discriminant is b squared minus 4ac, so it's 36. Hence a values are minus b plus minus root d over 2a. So it's negative 8 over 2 negative 4 or negative 2 plus 6 4 over 2 2, and hence the possible values of a are negative 4 and 2. And that's all for this question.